this video, we are going to discuss how to find the oxidation number of different elements in a chemical compound. So that we have to remember some rules. Let's see what are they. Oxidation state of any ion is equal to its charge. Let's see. Let's think. Calcium, its charge is +2, so that oxidation number of calcium ion is equal to +2. Chloride ion, Cl-, so its oxidation number should be -1. Zinc, it is 2+, so oxidation number is equal to +2. And also we have to remember the sum of the oxidation numbers in a polyatomic ion is equal to the charge of the ion. Let's see. Let's think. Polyatomic ion, manganate, MnO4-. So here oxidation number of this whole polyatomic ion is equal to -1. Chromate, Cr(O4) to minus. What is it? Its oxidation number should be -2. And also you have to remember group 1A always have +1. Here we consider only the metals in 1A. They always show +1. And group 2A, these elements always show +2. Next one, oxidation number of any pure element is 0. Let's see. Magnesium, it is a pure element, so that oxidation number is equal to 0. Calcium, it is also equal to 0. Cl2, it is 0. N2 also equal to 0. P4, it is also equal to 0. Here, no matter how many atoms have combined in the same type, as they have only one pure element, oxidation number is always equal to 0. Then let's see, the sum of the oxidation numbers of all the atoms in a neutral compound is 0. Here calcium carbonate, in the whole compound, sum of each oxidation number of each element is equal to 0. Potassium chloride, it is also equal to 0. And let's see about the hydrogen. Hydrogen with metals show -1 and hydrogen with non-metals show +1 as the oxidation number. The reason is electronegativity. Electronegativity value of hydrogen is 2.2. Here you can see it is more than the metals and it is less than the non-metals. So that hydrogen with metals show -1 while hydrogen with non-metals show +1 as the oxidation number. Fluorine always show -1 because it has the highest electronegativity. Most halogens show -1, usually fluorine and chlorine. Let's see more examples when we are calculating the oxidation value. Now let's move to our last rule. Oxygen usually shows -2. It shows +2 only with OF2. Right, let's see how it shows +2 with OF2. Here, now we are going to find the oxidation value of oxygen in OF2. Let's take it as simple X. And you can see here there are 2 fluorine atoms. Sum of them should be equal to 0 because In a neutral compound, sum of the oxidation numbers of each compound should be equal to 0. Except we know fluorine always show -1. Here it has 2 fluorine atoms. 2 times -1 should be equal to 0. So x minus 2 is equal to 0. We know when we are taking -2 to the other side, it will convert into positive. So x is equal to +2 here. X means oxidation number of the oxygen in OF2. -1 in peroxides and -12 in superoxides. Okay, let's see. In peroxide ion, oxygen show -1. Let's see what is the reason for it. Here you can see there are 2 oxygen atoms. Sum of the oxidation number should be equal to its charge. It is -2. We have to find the oxidation value of one oxygen atom. For that, we have to divide both sides by 2. Then 1 oxygen atom is equal to -1. In the superoxide ion, we can see there are 2 oxygen atoms. Its charge is equal to -1. So, to find the value of one oxygen atom, we have to divide both sides by 2. Then, oxidation number of oxygen is equal to -12. Now, let's consider some examples. Let's find the oxidation number of Hg here. Here you can see there are 2 mercury atoms. Its oxidation number should be equal to +2 because its charge is +2. So, to find the oxidation of one atom, we have to divide both sides by 2. Then Hg is equal to +1. In the second example, let's find the oxidation number of sulfur. Here you can see there are 2 hydrogen atoms and 1 sulfur, 4 oxygens. Sum of their oxidation numbers should be equal to 0. Here hydrogen has combined with a non-metal. So hydrogen shows +1. 2 times 1. Let's consider the oxidation number of sulfur as x. Add. It is not a superoxide or peroxide, so oxygen shows -2 here. It should be equal to 0. So 2 at x minus 8 is equal to 0. X is equal to +6. Let's find the oxidation number of aluminium here. Aluminium at 3 fluorine atoms. Oxidation number should be equal to 0. Aluminium, let's take it as simple x. Fluorine always show -1. 3 times -1 is equal to 0. X is equal to +3. Here, let's find the oxidation number of chlorine. Chlorine at 4 oxygen atoms. their oxidation number should be equal to -1 because its charge is -1. Let's take the oxidation number of chlorine as X. Add 4 times -2, it is equal to -1. So X minus 8 is equal to -1. X is equal to +7. Here, let's find the oxidation number of vanadium. 2V add 5O. Sum of the oxidation number is 0. Let's take the oxidation number of vanadium as simple X. Add 5 times -2 is equal to 0. 2x minus 10 is equal to 0. So 2x is equal to +10. X is equal, by dividing both sides 2, it is +5. Here let's find the oxidation number of manganese. Now we know X add 4 times oxygen show -2 is equal to -1 because it has -1 charge. X minus 8 is equal to -1. So X is equal to -1 plus 8. Value is equal to +7. Let's find the oxidation number of chromium. 2K. Add chromium at 4 oxygen atoms. Sum of their oxidation number is equal to 0. 1A always show +1. 2 times 1. Add, let's take it as X. Add 4 times -2 is equal to 0. 2 add X add X minus 8 is equal to 0. So X is equal to +6. The more examples here. Already we know sodium should be +1 because it is in the group 1A, and hydrogen is -1. What is the reason? Hydrogen has combined with a metal, so hydrogen has to show -1. Let's see here. Hydrogen has combined with a non-metal, so chlorine has the highest value. It should be -1, and hydrogen have to bear +1. BH3, let's find it. Hydrogen has the highest value than boron, so that B at 3 hydrogen atoms is equal to 0. Boron at 3 times -1. Why we take it as -1? Because hydrogen has the highest electronegativity value than boron. It is equal to 0. So boron has oxidation number +3. H2O. Here oxygen shows -2, and there are 2 hydrogen atoms, one bear positive 1. In ammonia, nitrogen, here hydrogen has combined with a non-metal so that hydrogen have to bear positive 1 as the oxidation number, so N add 3 times positive 1 is equal to 0, so nitrogen has the oxidation number of plus 3. Okay, at last let's consider these 3 chemical compounds. Here you can see all of them are halogens, so when you are finding the oxidation number of them, you have to remember when moving up in the halogens column, electronegativity value is increased. Right, so fluorine has the highest value than chlorine, so let's take chlorine as X. Add 3 times minus 1 should be equal to 0, so value of the oxidation number of the chlorine is equal to plus 3. In BrCl3, chlorine has the highest value, so bromine add 3 times minus 1, it is equal to 0, so value of the oxidation number of bromine is equal to plus 3. When we are considering IBr5, bromine has the highest value because iodine is below than the bromine, so I add 5 times minus 1 is equal to 0, so value of the oxidation number of iodine here is plus 5. Here the only one rule you should remember, fluorine has the highest electronegativity value. When moving up towards the halogens column, electronegativity value is increased. Hope you are enjoying this video and don't forget to subscribe us on the YouTube. Thank you.